Welcome to the final video of this mini course. Let's see how we can implement a simple moving average filter in C. As an input to our filter, we will use the temperature measured by a thermistor. We will build upon the code we wrote in this video, and if you want to know in detail how to use a thermistor to measure temperature, I recommend you watch this video. Also, I will only go through the code that is relevant for this course. That being said, let's get started. The first thing we have to do is define the length of the moving average window. That's just the maximum number of samples we will be using for our statistical calculations. So this macro here represents big N from our previous video. Next, we have our moving average filter structure here. In it, we have our window, which will contain the measurements, an index to keep track of where we need to store our latest measurement, and a sample counter that tells us how many measurements are already in the window. So this counter is equivalent to little n from the previous video. We also have our sum of squares and sum of cubes here. These were labeled S sub k and C sub k in our derivations throughout the course. And last but not least, we have our statistical parameters here: the average value, the standard deviation, and the skewness of our measurements. These three parameters are the output of our filter. Moving on, here we have our init function. All we do here is make sure we don't proceed with the function if a null pointer was passed into it, and set all the fields of our moving average filter structure to 0. Now, here we have our filter update function. In it, we update our statistical parameters based on our latest input sample. Just like before, we first make sure a null pointer wasn't passed into our function. Afterwards, we define a flag that tells us if our window is already full. This flag is equivalent to f from our previous video. Next, we update the sample counter and saturate it right after, because its value can never be bigger than the number of samples in our window. Here we have our oldest sample. We keep it equal to 0 until the window gets full. After that, we set it to the value that will be rolled over after we finish calculating our statistical parameters. Also, here we have our previous average, and here we calculate our delta average and update the current average right after. Next, we define delta S1 and delta S2, and after that we update the sum of squares and calculate the standard deviation. Now here we define a temporary variable as the difference between the delta average and the previous average. This is just the variable t from our previous video. Here we update the sum of cubes and calculate our skewness coefficient. Notice that this here is delta c from our previous video. That concludes our statistical calculations. Now all that's left to do is roll over the oldest measurement and update the sample index. Finally, we return a proper error code, and that concludes our filter update function. To illustrate how to use our moving average filter, in our main function, we declare a moving average filter structure and initialize it. In our while loop, we periodically take a temperature measurement and update our filter with it. After that, we print our results. To verify that our implementation is correct, we created a test structure here that contains a buffer for our measurements, an index, and a sample counter. It also contains the statistical parameters we will use as a reference. Afterwards, in the while loop, we calculate the average value, the standard deviation, and the skewness of our measurements using for loops and print the results. If the results match, it means our moving average filter implementation is correct. Now let's run the code and see what we get. It seems that the results we get from our moving average filter match our test values, which means we implemented our filter properly. We only printed 50 iterations here, however, our average value doesn't seem to vary much, the standard deviation is low, and also the data wasn't much skewed. And that's it for this video. We reached the end of this mini course. I hope you found it helpful. If you did, consider buying me a coffee using the link in the description of this video. Thanks for watching, good luck with your work, and I hope to see you again.